with us tonight one of our own Montgomery Amateur Radio Club members, John, K3LO, who will talk to us about the Global Maritime Distress and Safety System, GMDSS. In other words, how ships in distress call for help. And hint, hint, it isn't sending SOS on CW or Mayday on SSB because nobody would hear it. So thanks so much, John, for taking time to do this presentation on this very interesting topic. And now it is over to you.
Thank you, Alex, and good evening, all ships and stations. This is John O'Brien, K3LO. This evening, I'll be speaking about the Global Maritime Distress and Safety System. This will take about 45 minutes. I'm going to stop my video to avoid any bandwidth issues, and I'm going to share my application. The Global Maritime Distress and Safety System is how a ship in distress calls for help. Distress situation means that a ship or aircraft or person is in grave and imminent danger and requires immediate assistance. Our story begins on the night of 14 April 1912. All of these times are in ship's time on the Titanic, which was 2 hours ahead of Eastern Standard Time. The radio operator on the Californian went off watch at 11:30 p.m. on 14 April. The Titanic struck an iceberg at 11:40 p.m. The first distress call from the Titanic was sent at 12:17 a.m. on the morning of 15 April. The radio operator on the Carpathia, which was 40 miles away from the Titanic, copied the Titanic's distress call. The radio operator on the Californian, which was 10 miles away from the Titanic, never heard the Titanic's distress call. He was off watch. The Titanic sank at 2:20 a.m. The Carpathia arrived at the Titanic's position at 4 a.m. The seafaring nations of the world made sure this would never happen again. The second radio telegraph conference had been scheduled for July 1912 in London, well in advance of the Titanic's voyage. It was held as scheduled, and on 5 July 1912, the contracting government signed the Second Radio Telegraph Convention. The first international convention on the safety of life at sea was signed in London on 20 January 1914. These conventions were amended many times. As a result of these international agreements, a radio telegraph station was required on all passenger ships, irrespective of size, and cargo ships of 1,600 gross tons and upward. For the purpose of the radio regulations, a passenger ship is any ship that carries 12 or more passengers for hire. A cargo ship is any ship that is not a passenger ship. A gross ton is not a unit of weight. A gross ton is a unit of volume. 1 gross ton is equal to 100 cubic feet. The gross tonnage of a ship is the volume enclosed by the ship. Radio telegraph is the on-off keying of a radio frequency carrier using the International Morse code. The Maritime Mobile Service refers to it as radio telegraph. The amateur radio service refers to it as CW. Ships which were required to have a radio telegraph station were also required to have a radio telegraph auto alarm receiver. The radio telegraph auto alarm signal was 12 4-second dashes separated by 1-second spaces. If the radio telegraph auto alarm receiver decoded 4 of these dashes, it would activate alarms in the radio room, in the radio operator's cabin, and on the bridge. Even if the radio operator was off watch and asleep, the radio telegraph auto alarm would awaken him and he would go running to the radio room to copy the distress message. During the 1920s, amplitude modulation was perfected. Eventually, a radio telephone station was required on cargo ships of 300 gross tons and upward, which did not have a radio telegraph station. Back then, it was double sideband full carrier amplitude modulation. Later on, it was single sideband suppressed carrier. But CW performed much better with weak signals and poor conditions. Amplitude modulation and single sideband never seriously challenged CW. During the 1940s, radio teletype was perfected. Radio teletype was very good for moving large volumes of traffic, but CW still had better performance with weak signals and poor conditions, and radio teletype never seriously challenged CW. On 11 February 1970, the International Radio Consultative Committee, which later became the International Telecommunication Union, adopted the recommendation for simplex teleprinting over radio, or SITOR. SITOR has error correction. The SITOR operator does not have to know Morse code. SITOR allows some coast station operations to be automated. SITOR is compatible with single sideband. Now CW had some serious competition. On 26 July 1974, the International Radio Consultative Committee adopted the recommendation for digital selective calling, or DSC. DSC is a protocol for sending and receiving pre-formatted digital calls via terrestrial radio. We'll go into more detail about DSC later in this evening's presentation. On 19 February 1976, the ComSat Corporation launched the first Marisat satellite to provide communications for ships at sea. At this point in time, satellite communications were not readily available and were very expensive. From this point going forward, satellite communications became more available and less expensive. Now terrestrial radio had some serious competition. On 10 November 1988, the International Maritime Organization adopted the recommendation for a new Global Maritime Distress and Safety System, or GMDSS. Most notably, the new Global Maritime Distress and Safety System did not include any provision for CW. On 1 February 1992, the seafaring nations of the world commenced phasing in requirements for the new Global Maritime Distress and Safety System. On 31 August 1993, the U.S. Coast Guard discontinued all medium frequency CW services. Effective 8 February 1996, on 1 April 1995, the U.S. Coast Guard discontinued all high frequency CW services. Effective 8 February 1996, ships equipped with GMDSS were no longer required to have a radio telegraph station. That was pretty much the end of CW outside of the amateur radio service. On 1 February 1999, the seafaring nations of the world completed phasing in requirements for the new Global Maritime Distress and Safety System. On 31 March 2012, the U.S. Coast Guard discontinued all SITOR services except broadcasts of maritime safety information. On 1 August 2013, the U.S. Coast Guard discontinued all medium frequency voice and digital selective calling services. On 7 February 2022, the U.S. Coast Guard discontinued monitoring high-frequency voice distress frequencies in the contiguous United States and Hawaii. Now there are only 3 ways to call the Coast Guard using terrestrial radio: high-frequency digital selective calling, VHF digital selective calling, and VHF FM voice. The Global Maritime Distress and Safety System is the technical, operation, and administrative structure for maritime distress and safety communications worldwide. The objective of the Global Maritime Distress and Safety System is to deliver a distress alert from a ship in distress to a rescue coordination center. The Global Maritime Distress and Safety System is mandatory for all passenger ships regardless of size and cargo ships of 300 gross tons and upward. GMDSS equipment requirements depend on the intended operational area or the intended area of operation. A ship must be able to send a distress alert by at least 2 independent means. There are 3 independent means of sending a distress alert in GMDSS. Emergency Position Indicating Radio Beacon, or EPIRB, satellite, and terrestrial radio. When activated, the EPIRB transmits an alert signal on 406.025 megahertz. The alert signal is received by satellites. The EPIRB transmits an identification number. If the EPIRB has been registered, the appropriate authorities can identify the station in distress. Newer EPIRBs have an internal GPS receiver and transmit their position. Older EPIRBs do not transmit position information. The satellites measure the Doppler shift. The Doppler shift measurements can be used to calculate the position. Data from the satellites is downlinked to a local user terminal, and the local user terminal sends the information to the appropriate rescue coordination center. These are EPIRBs. An EPIRB will float. It may be mounted in a hydrostatic releasing mechanism, which will release the EPIRB if it's submerged. Once it's released, the EPIRB will start transmitting. Do not disturb an EPIRB unless it's an actual distress situation. It may activate automatically if you do. In an actual distress situation, if you see a cylindrical shaped device, 4 to 6 inches in diameter, 18 to 24 inches in length, high visibility yellow or high visibility orange in color, grab it and take it into the lifeboat with you. It may not be an EPIRB, it may be another search and rescue locating device. In either case, it's a good thing to have in a lifeboat. When you're in the lifeboat, turn it on. The EPIRB has an on button, and the EPIRB also has a test button. You have to make sure you're really turning it on and not just activating the self-test feature. After you've turned it on, mount it as high as possible in a vertical position. There are lots of satellite services which provide reliable communications and could be used to call for help in a distress situation. 3 satellite services are fully compliant with GMDSS: Inmarsat-C, Inmarsat Fleet Broadband, and Iridium GMDSS. They all work the same way. The ship in distress sends a distress alert to the satellite. The satellite sends the distress alert to a land-earth station, and the land-earth station sends the distress alert to the appropriate rescue coordination center. Inmarsat-C is a store and forward service. By way of analogy, the SMS text messaging service in your cell phone is also a store and forward service. Inmarsat-C provides message service and data service. Inmarsat-C does not provide voice service. This is an Inmarsat-C terminal. It has a touchscreen display. It has the current position and the UTC time. These are both provided by the GPS input. Now, notice in the lower right, there's a clear plastic spring-loaded cover with a red button marked distress underneath it. If you press and hold this button for 5 seconds, the Inmarsat C terminal will transmit a distress alert. Within a few minutes, you should receive an incoming message from the Rescue Coordination Center acknowledging receipt of the distress alert. Inmarsat Fleet Broadband is a high-capacity shared channel internet protocol service. Inmarsat Fleet Broadband provides voice service and broadband data service. Inmarsat Fleet Broadband by itself is not compliant with GMDSS. Inmarsat Fleet Broadband with a Maritime Safety Terminal is fully compliant with GMDSS. This is an Inmarsat Fleet Broadband Maritime Safety Terminal. Notice on the right, the red plastic spring-loaded cover marked distress with a red button marked distress underneath. If you press and hold this button for 5 seconds, the Inmarsat Fleet Broadband terminal will transmit a distress alert. You should receive an incoming message from the Rescue Coordination Center acknowledging receipt of the distress alert. Iridium GMDSS provides voice service, message service, and data service. This is an Iridium GMDSS terminal. It has the current position and the UTC time. Both of these are provided by the GPS input. Notice here on the upper left, the red plastic spring-loaded cover marked distress with a red button marked distress underneath. If you press and hold this button for 5 seconds, the Iridium GMDSS terminal will transmit a distress alert. Immediately after transmitting the distress alert, it will dial a satellite telephone call to the Rescue Coordination Center. So you should get an incoming message from the Rescue Coordination Center advising you that they've received your distress alert, and you should also be talking with them on the telephone. Now our favorite, terrestrial radio. Before discussing global maritime distress safety system distress alerts using terrestrial radio, let's review the distress communication procedures in the amateur radio service. We'll go to the ARRL General Class License Manual, page 218, 2-18. Okay, so it says first, if you hear a distress signal, immediately suspend your existing contact, if any. That's very important because you do not want to be interfering with the distress call. Then immediately acknowledge to the station calling for help that you hear them. The station in distress will probably change frequency if he or she makes the distress call and nobody acknowledges it. You want to avoid a situation where a station changes from a frequency where you're hearing them to a frequency where nobody's hearing them. Okay. Stand by to receive the location of the emergency and the nature of the assistance required. Relay the information to the proper authorities and stay on frequency for further information or until help arrives. Now, if you're the station making the distress call, on a voice mode, say the radio telephone distress signal 3 times, or on CW or digital mode, send the CW distress signal 3 times, followed by any station come in, please. Identify the transmission with your call sign, state your location with enough detail to be located and the nature of the situation. Describe the nature of assistance required and give any other pertinent information. Okay. So when using terrestrial radio, a ship sends a distress alert to a coast station, and the coast station sends the distress information to the appropriate rescue coordination center. So I've mentioned digital selective calling several times. Digital selective calling is a protocol for sending and receiving pre-formatted digital calls via terrestrial radio. Digital selective calling operates in the medium frequency, high frequency, and VHF bands. Some types of DSC calls are distress alert, distress acknowledgement, distress relay, request to establish two-way communications with another station. A DSC distress alert consists of the identification number, the nature of the distress, the default is undesignated distress, the position, the time in UTC that the position was determined, and the mode for follow-on distress communications. The available options are voice or SITOR. But remember, the Coast Guard discontinued SITOR services back in 2012. So even though you have an option to use SITOR, always use voice for follow-on distress communications. DSC calls can be addressed to an individual station, a predefined group of stations, stations in a geographic area, or all stations. And a distress alert would be one of the calls that's addressed to all stations. An incoming DSC call activates audible and visual alerts on the DSC receiver. A DSC call is analogous to the ringtone on your cell phone. It lets you know that you have an incoming message or that someone wants to establish two-way communications with you. This is a medium frequency and high frequency transceiver. It has a high power setting of 150 watts and a low power setting of 20 watts. You can see in the display that it's on the low power setting. The display is a thin film transistor display with soft keys. It's in the nighttime display, which is red text on a black background. The GMDSS equipment has to be located on the bridge, and bridge watchstanders are very concerned about preserving their night vision. Red light is okay for their night vision. It has the current position and the current UTC time. Both of these are provided by the GPS input. It supports single sideband and SITOR and digital selective calling. It does not support CW. Notice here on the lower left, the clear plastic spring-loaded cover with a red button marked distress underneath. If you press and hold this button for 5 seconds, the transceiver will transmit a digital selective calling distress alert. If everything works the way it's supposed to, you should receive a digital selective calling distress acknowledgement from a coast station. One very important difference between this transceiver and an amateur radio transceiver is what the operator is able to do with the transmitter. All amateur radio operators of all license classes are authorized to make adjustments which affect the proper operation of their transmitters. For example, an amateur radio operator can adjust the power output, microphone gain, speech processing, ASC level, transmit filter width, and other parameters of his or her transmitter. Some classes of commercial operator licenses are not authorized to make adjustments which affect the proper operation of a transmitter. The only thing they can do with the transmitter is to toggle between a manufacturer-determined high power setting and a manufacturer-determined low power setting. This is a VHF FM transceiver with digital selective calling. It has a high power setting of 25 watts and a low power setting of 1 watt. You can see in the display that it's on the low power setting. The display is a thin film transistor display with soft keys. It's in the daytime display, which is black text on a white background. It has the current position and the current UTC time. Both of these are provided by the GPS input. It supports FM voice and digital selective calling. Notice here in the lower left, the clear plastic spring-loaded cover with the red button marked distress underneath. If you press and hold this button for 5 seconds, the transceiver will transmit a digital selective calling distress alert. If everything works the way it's supposed to, you should receive a digital selective calling distress acknowledgement from a coast station. The VHF FM DSE transceiver is set to channel 16, which is the VHF FM distress and calling channel. Channel 16 is 156.8 megahertz. Most amateur 2-meter FM equipment has a receive range of 136 megahertz to 174 megahertz. If you're near the water, you could set your 2-meter handheld to 156.8 megahertz and listen. The current VHF channel numbering scheme is 2 digits and possibly an A or a B. The FCC is very slowly migrating to a new channel numbering system, which will be 4 digits with a 1 as the leading digit. GMDSS equipment may be standalone or may be integrated into a console. This is a GMDSS console. Here on the right, we have an Inmarsat C terminal. And again, notice the red button at the lower left. At top center, we have a medium frequency and high frequency transceiver. Again, notice the red button on the lower left. At the center bottom, we have a VHF FM DSE transceiver. Notice the red button on the lower left. On the left, we have a Cytor terminal. And again, notice the red button on the lower left. So we've discussed how you would send a distress alert using digital selective calling. What about if you receive a DSC distress alert? An incoming DSC distress alert will activate a distinctive 2-tone alarm. First thing you have to do is silence the alarm. Depending on the manufacturer, there may be a silence or silent touchscreen icon. There may be a silence or silent soft key, or you can press any button to silence the alarm, but not the distress button. Do not acknowledge receipt of a DSC distress alert by using DSC. Only appropriate coast stations should acknowledge receipt of a DSC distress alert by using DSC. I know that's hard to believe, so here it is in the Code of Federal Regulations. And the reason you don't want to acknowledge a DSC distress alert is the equipment is automated and will keep repeating the distress alert until it receives an acknowledgement. Well, the objective is to get the distress alert to a coast station. And that's why only coast stations should acknowledge the DSC alert and stop the repetition of the DSC distress alert. What you should do is wait 5 minutes to allow a coast station to respond. While you're waiting, listen on the voice distress frequency in the same frequency band that the DSC distress alert was received. Write down the distress information from the display and notify the person in charge of your vessel as soon as possible. What you're hoping for is that you will hear a coast station issuing a DSC acknowledgement. The next best thing would be if you heard a coast station calling the station in distress on the voice distress frequency. If you do not receive a distress alert acknowledgement from a coast station, or if you do not hear distress traffic on the voice distress frequency, then you should acknowledge receipt of the distress alert on the voice distress frequency in the same frequency band that the DSC distress alert was received. And get the distress information to the proper authorities by any means. One option to do this is the DSC distress relay. If we go back to the medium frequency and high frequency transceiver, this is the high level menu. You see one of the soft keys is marked relay. If you press the soft key next to relay, this will take you to another menu where you can compose and send a distress relay. If we look at the VHF FM DSC transceiver, we see a soft key here that says DROBOS. That stands for distress relay on behalf of someone else. If you press this soft key, it'll take you to another menu where you can send a distress relay. Now, why would you wait 5 minutes to send a distress relay? Why not send the distress relay immediately upon receipt of a distress alert? Because if several stations heard the initial distress alert and they all sent distress relays, too many distress relays would overwhelm the DSC receiver at the coast station or any other DSC receiver within range. And that's the end of our story. Back to you, Alex.